Our lesson goal for today will be to divide fractions, rational numbers. When we're dividing rational numbers, it's going to be very similar to when we're multiplying rational numbers. We're going to have 1 to 2 extra steps. The first step is to rewrite the divisor, in this case, 8 over 5 as 5 over 8. And we're going to change the division into multiplication. When canceling, we can cancel vertically or diagonally. We cannot cancel horizontally. When we look to cancel vertically, we can see that 6 and 15 do have a common factor of 3. 3 goes into 6 twice, and 3 goes into 15 5 times. When we look diagonally, we see that we have a 5 and a 5. So therefore, 5 is always a factor of itself. So 5 divided by 5 is 1. Now we can see we have 2 and 8, which have a common factor of 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. Now we'll multiply across. 1 times 1 is 1, and 1 times 4 is 4. By the end of this lesson, I'll be able to divide fractions with canceling. Real numbers are represented by the letter R. Rational numbers now can't be represented by the letter R since real numbers have it, so we use the letter Q for quotient. Fraction 9 over 4, which is 9 divided by 4. When we write it, 4 goes into 9 2 times. 2 times 4 is 8. 9 minus 8 is equal to 1. 1 becomes the numerator or our divisor. Thank you so much, Ilani and class, for saying it so perfectly. You may want to pause to try to simplify this fraction. 7 divided by 2. 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. Our remainder becomes the numerator of our divisor. Two numbers whose product is 1 are reciprocals. To write the reciprocal of a number, write the number as a fraction, then invert the fraction. So the reciprocal of a fraction a over b is b over a, where a and b do not equal 0. When you invert a cup, all you have to do is flip it over. We'll come back to this concept in a moment. We are right here on our guided notes. What's the reciprocal of 2/3? This means that the reciprocal of 2 over 3 is 3 over 2. What's the reciprocal of 2? This means that the reciprocal of 2 is 1/2. What's the reciprocal of 1/3? 3 over 1. This means that the reciprocal of 1/3 is 3, because 3 over 1 can be simplified to just 3. What's the reciprocal of 0? Well, when you try to write the reciprocal of 0, you get 1 over 0. You cannot have 1 over 0 or any number over 0. It is not a real number. Sometimes we call this undefined. We will revisit this concept of undefined in later chapters. Pro tip: when any number is multiplied by 0, the product is 0. So the number 0 does not have a reciprocal. Reciprocal is also known as multiplicative inverse. In the word multiplicative inverse, you can see we have that root word invert. Remember, when you invert a cup, all you have to do is flip it over. AKA means also known as, meaning just another name for. Therefore, when I say, hey, find the multiplicative inverse, I'm saying find the reciprocal. It's just another word for reciprocal. Therefore, what's the multiplicative inverse of 7/8? 8 over 7. Another pro tip: the product of a non-zero number and its reciprocal is 1. A over b times b over a will equal 1. This is called the multiplicative inverse property. The product of 8/9 and 9/8, which are reciprocals, we can see that we can cancel. 8 goes into 8 one time, and 9 goes into 9 one time as well. When we multiply across, we get 1 times 1 over 1 times 1, which is 1 over 1, which is simply just 1. Division is the same as multiplying by the reciprocal. Therefore, if division is the same as multiplying by the reciprocal, it's the same as multiplying by the multiplicative inverse. Are you hungry for some Kentucky chicken fried? Yes, I said Kentucky chicken fried. That's for keep, change, flip. When we are dividing, we're going to keep the dividend the same, change the operation to multiplication, and we're going to flip the divisor. Now, it's just a multiplication problem. We can see that diagonally, 8 and 6 have a common factor of 2. Therefore, 2 goes into 8 4 times, and 2 goes into 6 3 times. Now we can multiply across, and we get 20 over 27. Very similar to multiplication, just one extra step in this case. Same thing, keep, change, and then flip. We're going to try to cancel. I can see I can cancel vertically. 9 and 12 have a common factor. 3 can go into 9 3 times, and 3 can go into 12 4 times. No other common factors vertically or diagonally, so we're just going to go 3 times 7 over 4 times 5. In this case, we have an improper fraction. We can see that we have 1 extra, so we can write 1 and 1/20th, or we may want to do the work. 20 goes into 21 one time. 1 times 20 is 20. 21 minus 20 is 1. We write our remainder as the numerator to the divisor. Let's take a look at another example. Keep, change, and then flip. We could cancel. 18 and 3 have a common factor of 3. 10 and 25 have a common factor of 5. Now we can multiply across, and we're left with 12 over 5. Again, an improper fraction. This one's a little bit tougher to see. If you're doing mental division, 5 goes into 12 2 times with 2 left over. So we have 2 and 2/5. If we want to see it visually, 5 into 12 is 2. 2 times 5 is 10. 12 minus 10 is 2. And we put our remainder over a divisor. When we're dividing mixed numbers, we're going to first change these mixed numbers into improper fractions. Remember, we take the whole, multiply by the denominator, and add it to the numerator. 3 times 4 is 12, plus 3 is 15. 2 times 7 is 14, plus 1 is 15. So we have 15 over 4 divided by 15 over 7. Now we'll keep, change, and flip. Notice we have 15s that can cancel out. And we're going to multiply across. 1 times 7 over 4 times 1 is 7 over 4. In this case, we'll have 3 more than the 4, so it's 1 and 3/4. If we're looking to do it visually, 4 goes into 7 one time. 1 times 4 is 4. 7 minus 4 is 3. And our remainder becomes the numerator to our divisor. We are now on the back of our guided notes. Complex fractions. A complex fraction is a fraction that has a fraction in its numerator, denominator, or both. When we are simplifying a complex fraction, we're going to write the numerator just like it is. This longer bar or bold bar is going to either be longer or thicker, is our division symbol. And then we're going to rewrite the denominator just like you see it. And then it becomes just like a problem that we did earlier. So let's take a look at this one. 8/9 divided by 2/15 is equal to 8/9 divided by 2/15. Then we're going to use keep, change, flip. We're going to keep the first one, change the operation, and flip the second one. We can see we could cancel. 2 goes into 8 4 times, 2 goes into 1 time. 3 goes into 15 5 times, 3 goes into 9 3 times, multiply across, and we're left with 20 over 3. Since this is an improper fraction, we can divide. 3 goes into 20 6 times, 6 times 3 is 18, 20 minus 18 is 2. That's my remainder, goes over my divisor, so my final answer is 6 2/3. When we take a look at this one, when we only have a fraction in the numerator, we're just going to rewrite the denominator as a fraction. And then it works the same way out. 8/9 divided by 2 over 1. When we have a fraction only in the denominator of the complex fraction, we're going to rewrite the numerator as a fraction, so it's 8 over 1. Therefore, this would be 8 over 1 divided by 2/15. and then we work it the same way out. Keep, change, flip. This concludes our lesson.